Boom. In theory, it's live, but we really need some human being to let us know that we exist. We're currently Brady Bunched, but you guys can't tell. You won't even know when I'm putting up cool videos and pictures. I gotta solve this one. I gotta be able to create a virtual camera inside the computer that shows you the results of the output stream. And I used to have a broadcast software that did that, but now I don't.
Oh, there it is. I see it.
Yeah. You just watch YouTube like a regular person, and you'll see it. We made it. Hey, Tom McIntyre made it to a live cast. I'm going to say hi to everybody in a second, so you're going to want to say hello in the chat, and then I'll say your name in a second. I have no idea why the Slack chat is all messed up. It's the same every week. How can this be different? I don't understand. I don't do anything different to it. I changed but now, like, why does it have my message thing at the bottom? I don't know. Technology! Yeah. Because now
idea.
Now it just shows this is no good. Okay, I'm gonna fix this, but then it's gonna jump around. You're all just like, I don't care.
I don't even know.
I don't even know what you're talking about, Fraser. I do not care. There. So yeah, move the...
Well, what else is new?
Yeah, I know. Welcome to the new world. Yeah.
I liked the old one.
Yeah. No, we're never going back to the old world.
Oh.
No. This is change. Change, as Thomas Tranneker says, change is constant, especially from me.
Change is constant.
Constant grinding.
I'm pretty sure that's
change.
an oxymoron. That's okay.
Constant grinding change. Yeah, my microphone made a terrible noise because technology. Yeah, I am totally. Daniel McCool says I'm turning into a Luddite. Yeah, I think the more you use and rely on technology, the more Luddite you become. You know, if a cotton gin comes anywhere close to me, I'm taking a sledgehammer to it. Cotton ginny? I forget what it is. Yeah. Fraser versus Google round 7. Okay, I'm gonna say hi to people now. If I can even figure this out. Whoa, they've changed names. Okay. Hello to Adam Synergy, Age of Atheism, Benjamin Valamont, Billy Gordon, Brian Yoko, Carolyn B, Chris Clark, Christopher Green, Citizen Gold, Colin James, Daniel Evans, Daniel McCool, Darren Springle, Doug Joseph, Elad Avron, Endo, Eric Knapp, Gary Nielsen, Gerald Everett, Giselle Sabarin, Guido Bibra, Henrik Bo Anderson, Hogarth Okanovic, that's a new one, Hugo Burnham, James Doyle, John Gallant, John Suffield, Julius Stanionis, sounds Greek, Jorn Albert, Lillian Brennan, Linda Sadek, Malcolm Bond, Michael Cassidy, Michael Meyer. This is a lot of people. Nancy Graziano, Neil Hutchinson, Neil Gurry, Paul from AstronomyNJ.com, Physics Police. Physics Police are here, so everyone be careful. Watch your limits, speed limits of light. Pyro Nitro, Aaron Stroh, Roberto Gurgle, Ron Hook, Ronald McCoy, Ryan Schmitz, Ryo San, Sergio Botero, Seth Cooper, Sev Dust Bunny, Sylvan Westby, Tech Tang. See, I'm telling you, it's a lot of people. Thomas Tranneker, Tom McIntyre, True Astronomy, Vapiz, Vendetta Vegan with a Vendetta, and Zapfan. Hello, everybody, and welcome to this week's episode of the Weekly Space Hangout. A very special episode. No, it's exactly the same. We don't have a special guest, though, so I guess it's not.
We're all special.
We're all special. Yeah, we are equally special. So just a reminder to all the people, I did not say there would be a prize this week.
Yeah, you did.
That would mean that you had watched last week, Paul, and we know that's not true. So, but what was I going to say? Right. So, but anyway, we have no special guest this week. Very special episode. All right. A reminder that if you want to be notified when we start the broadcast, go ahead and put the little notification bell on, and then you're going to get a notification. And then you'll be like, the live stream has started. Where is Morgan? I don't know where Morgan is. He has a life outside of us. Yeah, this that,
I presume in Colorado somewhere.
somewhere in Colorado. Well, last time we saw him, he was, I think, at his parents' place, and he had gone home for Christmas. I'm not sure.
I have no idea.
He's
I was
only
in Dallas last week. I
he's
don't
only
know.
not been around for just a couple of weeks. I know we all miss him. We send his love. Well, I think we've hit our 5 minutes. You've all sat down, grabbed your space coffee, and you're ready for an episode of the Weekly Space Hangout. So let it begin. Thusly. All right. Hello, everyone, and welcome to the Weekly Space Hangout for Friday. Gonna look at my watch again. January 13th, 2017. I'm Fraser Cain, publisher of Universe Today. And joining us this week, no special guest, just a great big rundown of stories. We're going to be talking about a new, pretty cool update on what might be the cause for the alien megastructure Tabby star. Looking for where Voyager's going next out in interstellar space. Looking for the stuff of life in the universe. How breakthrough Starshot's going to be helping the hunt for planets, Earth seen from Mars, and a new star in 2022. Joining us this week, we've got, the computer says, Kimberly Cartier. Kimberly.
Hello.
Welcome to the Weekly Space Hangout.
Happy New Year, since I haven't seen any of you since last year.
And you're going to be our very special guest next week.
Yes, I will. I've been doing lots and lots of research that I will soon be defending for a PhD. So.
And you thought you'd defend it here first.
Yes,
Perfect.
I will defend it from our.
We'll invite your committee on, and it'll be a great time.
Oh, great! Impromptu defense, my favorite kind.
Perfect. That's going to be a lot of fun. Yeah. So you're a special guest, and but other future other special guests coming up. For example, just a reminder, we got Alan Stern coming up in about a month. So, we've got let's see, Paul Matt Sutter.
I'm here too.
Yay!
Yay.
No defense, no special guest. However, there's a very special trip that's going to be coming up in about a year from now.
A year from now, that's right. Very exciting. A trip to Iceland, a week-long excursion to go hunting for aurora and look at all the fascinating geophysical activity happening in Iceland. A trip guided by me and someone else in this space hangout.
Yeah, so that's
Fraser.
right. Paul
So
said,
cool.
have you ever wanted to go to Iceland and take pictures of the aurora? The answer is, of course, yes.
Of course, yes.
Of course, yes. And I just had never gotten organized to plan such a thing. So Paul has invited me. I'm going to attend. There's slots available. How does a person find out if they want to join us in Iceland in February 2018?
Yes. The trip is February 2018. The sign-up deadline is this August. You go to astrotouring.com, and that will nice little website where there's pictures of Iceland and descriptions of everything I just told you, and a form you fill out to get in touch with the travel agent, who will arrange all the booking details.
Right. And not a lot of slots. So if this is a thing that you want to participate in, you're going to want to hurry.
Like, do it now.
Do it right now.
Just turn off this show and go to astrotouring.com.
Yeah, I mean, we learned this terrible lesson from the eclipse that we need to have bigger hotels, make eclipses happen more often. I'm not sure, but we had like 200 slots for eclipse tour in August, and they were gone within a couple of weeks. So, I literally cannot wait to see the auroras, so that's super
It'll be really
exciting.
fun. It'll be cloudy the whole week, but
of course, but
buy your tickets first.
No, don't say that.
Oh no,
No,
that's not in the brochure. No, we have a good chance. We're spending like 4 solid nights hunting for aurora.
Yeah. And last but not least, we've got Carolyn Collins Peterson. Carolyn, welcome.
Hi.
You didn't show up here. Talk again. Say hello one more time.
Hi, it's me.
There we go. Awesome. All right.
Yeah, I envy you your trip. I just did the same thing in October.
I'm super, super excited. My bucket list. We just went to Costa Rica, and that was my wife's bucket list. We literally just went to the very top of her bucket list. So now we're going to go to the top of my bucket list and go to Iceland, although she's not coming. She hates the cold, so.
She's not coming?
No, it's just going to be me.
Well, I won't be holding on to that +1 for you.
All right. Okay, well, let's get on with the stories then. So first up, I have decided that we need, of course, to do the big update on what's happening with the alien megastructure star, because apparently there's a bunch of news came out. Maybe it's been answered. Kimberly, what do we
Not
know?
100% answered, but we have a few more firm ideas of what it could be. And none of them are alien megastructures. It's the only time I am saying those two words in the next hour.
Okay. All right. So
Right, so we last heard about Boyajian Star or Tabby Star when Jason Wright was on the show a couple weeks ago. But there have actually been a few, 3 or 4 papers that have been published since then, examining a bunch of the possible explanations in more detail and trying to see whether or not they're actually possible. So I have a few to go over.
okay,
And,
we're ready.
all right. Okay, so the 3 explanations that have been looked at in more detail are sort of the normal-ish one, which is that it's some sort of internal complication with the star itself, and that's sort of like humdrum, but it was looked at. There's the old reliable one, which is a stream of comets, and then there's a pretty cool one, which is that Boyajian star has merged with something, which I think is the coolest. So we looked at each of those.
Okay, yeah.
All right, so the first one, that something internal is happening to the star that makes the brightness variations happen. There's a group from University of Illinois at Urbana-Champaign that looked at this, and they modeled the timing distribution of all those strange dips, those transit-like events that aren't really transits. And they looked at the spacing of the dips and found that it follows a very common distribution that we see a lot in natural systems called a power law. A lot of natural systems in astronomy show this kind of distribution. So when they saw that the dips were spaced this way, they said, maybe something internal is happening, something actually physically motivated is happening. And they suggest that maybe there's some sort of non-equilibrium physics going on. Maybe something is like on the cusp of transition, like a magnetic field flipping, which we see in our sun every 11 years or so. And so maybe we're on the cusp of something like that, and that's causing this buildup of all these dips that are getting more and more frequent as time goes on. So that's a possibility. I don't think this is the first time we've looked at the spacing of the events for more than just a periodicity, trying to see if they happen at regular intervals. But the fact that they're actually in this particular power law distribution means it could actually be something physical happening within the star.
Something
Maybe.
physical, such as like the star consuming something?
Well, look at that transition to the next paper that we can talk about. Maybe not so much having eaten something, but if Boyajian star did eat something, like a small planet or a Jupiter or even a brown dwarf, another group at UC Berkeley and Columbia University just modeled the energy distribution that would happen from such an event, and their models show that right after Boyajian star would have eaten whatever it was, it brightens from all that energy and it slowly decays. And the question is whether the time scale of that decay matches with what has been seen from the Kepler data and possibly from the longer century-long archives of how fast Boyajian star has been dimming. They show that essentially no matter what Boyajian star eats, you can match the dimming rates that we see in our data.
You can, or you can. Okay.
You can. Both the dimming seen from the 4 years of Kepler data and also from the predictions from the century-long archives.
So weren't there problems with that century-long archive?
The century-long dimming is still very
reliability of that.
Yeah, the century-long dimming is still controversial, though I guess it depends on who you ask, which side of it you believe. I personally think that it could be happening because I think the person who originally postulated was the expert at reading those plates. So I think it's plausible. Either way, both of the dimming rates seen can be modeled from a dimming after a merger, but there's no real constraint as to what it's eaten, what the mass was, how long ago it's been.
Well, can you explain what process is going on that would cause the dimming after a merger? I mean, when we see, for example, Jupiter consume comets, they flare up, and we see the bruises on the surface of Jupiter. But if a star consumed some kind of a planet, what would cause that dimming?
It's essentially it's radiating away that energy and sort of distributing it more equally around the star as well. So it's essentially a dissipative process.
Like, is it cooling the surface of the star a little bit?
A little bit, yeah. So when they predict when it consumes something, all of the material and the energy that it's consuming gets spread out just over the very top layers of the star. It doesn't go anywhere near the core of the star at all. Just gets spread out throughout the envelope. And that energy, it's not supposed to be there in the star. And so it's the star just dissipates it away through radiation, through stellar winds and things like that. And it slowly gets back to its normal brightness, what it's supposed to be.
And so which of these do you like the best?
I think the idea that Boyajian star has consumed something, a planet or a small companion, is a very compelling idea. They also mentioned that maybe it could, like during the consumption process, maybe whatever it's eaten sort of disintegrated and left behind comets that maybe could cause those dips. That is also an idea. And if you can explain both of them at once, I think it's automatically at the top of my list of possible explanations.
And it doesn't seem surprising to me that objects fall into stars and get consumed.
It's not, though there is the caveat that it shouldn't happen too often. It's not a very likely event, and essentially you'd have to look at every single star of this type, these F stars. Essentially, you need every single system to be on the verge of doing this for Kepler to have caught one in its 4 years. It's very unlikely, and there's no real reason to guess why it would have done that.
Will TESS be able to assist in this, or is it not going to have any of the capabilities for this?
I would hope that TESS could help. I think as much monitoring as possible would be good, and I think what will really help sooner rather than later is actually the results of the Gaia mission, because it will tell us exactly how far Boyajian star is, which will tell us how bright it should be. So we'll get an absolute measurement of how bright it should be compared to how bright we observe it to be. Yeah. So we know how much brightening there is and the absolute numbers that we'll get from that will actually help a lot to constrain the models that are possible.
And then, of course, next week you'll be giving us more information and more from your perspective. So stay tuned, everyone.
Yes, definitely.
Awesome. All right, let's move on. Next up, I think we're going to talk about, what did I decide we were going to talk about next? We're going to talk with Carolyn about probing the nearby space between stars. So where's Voyager going now?
Well, both of the Voyager spacecraft are sort of at the edge of the, quote, edge of the solar system, at the edge of the heliosphere. And so they're essentially starting to probe the interstellar medium. Now, the story that I wrote about and that really caught my attention at the AAS, and let me digress a little bit. I was at the American Astronomical Society meeting all last week. And as you can imagine, with 2,200 astronomers talking about their science, there were some pretty good stories coming out, and this was one of them. And it caught my attention because it's got multiple stories packed into it. First of all, we have this interstellar medium, this bubble that we're passing through, called the local interstellar cloud. And there's actually more than one cloud in the area, but we're sort of in the middle of this 20, 30 light year wide cloud we're passing through. And that cloud is actually protecting us from radiation and sort of the other rigors of interstellar space. So that's what the heliosphere is pushing against, is this cloud. So here are the Voyagers out here at the edge of this thing, and they're basically probing the region here to be able to see how is it affecting our heliosphere? Is the heliosphere pushing back? That sort of thing. So they're sort of at that cusp, and then they're headed out through the cloud. They're headed toward a couple of stars. There's Gliese 445, I think, and the other one is Ross. I'm Ross 248. So they're headed out there in a few tens of thousands of years. They'll be there.
A few tens of thousands of years. That's all.
Yeah, I'm like, we're going to be getting data that long, right?
Yeah, yeah. Like they're not going to be in operation anymore.
No, but for a few decades or decade, maybe we'll get some more data from them. So they're giving us the in situ look of what's happening at this interface between the interstellar medium and the heliosphere. Well, okay, so that cloud we've known has existed for a while, and the thing that really caught my attention about this was 20 years ago when I was just finishing graduate school. I worked with one of the professors at the University of Colorado, a fellow named Jeffrey Linsky, who was using the Goddard High Resolution Spectrograph on Hubble Space Telescope to look at stars' light as it came through the local interstellar cloud. And he was measuring various things, the makeup of the cloud, what elements were in it. I think he was looking for deuterium, the ratio of that. He was looking for the extent of the cloud. So they looked at 16 clouds, stars in different directions, and were able to sort of map this cloud and the rate that it's moving at. And one of the things I helped him do was figure out how to explain this to the public, because he was doing a press conference at AAS, and it's kind of esoteric. I was on the GHRS instrument team at that time, so kind of understood what the science was. Well, fast forward 20 years, and here is a student, a senior in college, getting up, talking about using Hubble Space Telescope and a new instrument on board, the STIS, to look at stars, several stars, in the direction of travel of the Voyager spacecraft, and looking at those stars, and again, measuring the starlight as it passes through this cloud. So the thing that really caught my attention was that this is a multi-generational study. This is not just, we're looking at this cloud and we're looking how fast it's going, but multiple generations of astronomers can study this and learn something from it. It's pretty cool.
Yeah, I mean that the Voyagers are so far out now that they're starting to see the universe from a tiny little different perspective than what we see here on Earth. And over time, the signals that we get from them are going to continue to be useful to us long after they made their flybys of all of the large planets. How long will we?
Go ahead. Sorry.
I was going to say, how long will we be able to get signals from the Voyagers?
Yeah, it's in the order of decade, maybe.
Yeah.
It just depends on, something will fry and then we won't hear from them again. But right now they can measure magnetic fields and they can give us, a look at what's happening in that environment that they're passing through. And as long as they can do that, and mind you, they don't need very much signal to do this. I think I remember that they take less power than a handheld hairdryer, and so they're not even that much right now to be able to send back a little bit of this information. So we're basically getting the in situ data, basically meaning right there, and then Hubble is sort of giving us the big picture, looking back further at these stars.
And then how long till the Voyagers merge with some alien superintelligence and return to Earth?
Well, let's see, when does Star Trek? The 23rd century?
I think? 23rd century, right. And search for our whales. Awesome. Fantastic. All right, let's
it's a good way to look at the interstellar environment, which is not something that we know a lot about. We can probe it with starlight, and that's basically using spectroscopy, which is a whole other kind of topic of astronomy. But just be able to use starlight and be able to have it tell you by what's being absorbed, what kind of materials are in this cloud, really tells us a lot about what's going to happen to our heliosphere, how clumpy that cloud is, how much of it we're running into, where it thins out, where it's thick. The other thing too is, I remember Jeffrey was saying 20 years ago, we don't really know when we're going to move out of this cloud. It could be within 100 years. It could be 1,000 years. When we get out of it, then we're going to be in another whole regime of the interstellar medium.
And so the actual sort of density of the cloud surrounding us is changing over time as the solar system is pushing through these regions of the interstellar medium.
Yeah, it's visiting different parts of it, and essentially the cloud is moving and we're moving, so it's seeing different densities in the cloud.
Yeah, just amazing. All right, Dr. Paul Metz-Sutter, let's talk about we're going to talk about looking for the stuff of life.
Oh, we are talking about, I thought we were talking about a new star in the sky.
Well, we're going to talk about both, but we're going to talk
We're gonna
about
do both?
We're going to do both. Yeah, we're going to talk about the first one first, and then the next one.
Okay,
Next.
we'll do the first one first. That works for me. Yeah, so we're really interested in the distribution of elements in our galaxy, especially specific elements that are necessary for life as we know it. Things like carbon, nitrogen, phosphorus, sulfur, oxygen, all the good stuff that your body needs is it's really important, and we want to see where in the galaxy are these kinds of elements. Are they concentrated in certain parts? Are they evenly distributed? What kind of stars are these elements associated with? That helps us understand where life might come from. It helps us understand where life might be elsewhere in our galaxy. What are the chances of finding life in certain parts of the galaxy? And at the recent American Astronomical Society meeting, the Apogee group, which is part of the Sloan Digital Sky Survey, they've been looking for these elements around stars all over the place, and they found an interesting pattern. They found that the center of our galaxy, or regions near the center of our galaxy, are very, very rich relatively in these kinds of elements. So actually where our solar system is, about 2/3 of the way out in our Milky Way galaxy, is relatively poor in these kinds of elements compared to the center of our galaxy. And those elements appear to be rich in the center of our galaxy just because there's been a lot of generations of stars. There's been a lot of activity. There's been a lot of nebula turned to stars and back to nebula, back and forth again, more often than what's happening in the outer parts of the disk where we are. So if we're looking for life, or at least the building blocks of life, towards the center of the galaxy is a good direction to look.
And I mean, this is one of those questions, right? Like, does our galaxy have a habitable zone? But I mean, there are downsides of being closer to the center of the galaxy,
Absolutely.
Right?
Yeah. Near the center of the galaxy, the stellar density is much, much higher. The frequency of supernova, ionizing radiation, all that kind of horrible stuff is much worse. So maybe there's a trade-off where there's more chances of building life because you have the essential elements that you need, but any life that would get started would be immediately vaporized or irradiated.
Yeah.
So, one or the other.
And then on the flip side, right, you go further out than the sun, and you've got, less generations of stars, less heavier elements, and so you just don't have necessarily the same kinds of just raw ingredients. Where do
it's
we?
Like a city, there's more people in the city, but there's also more violent crime.
So where do we exist? That analogy is breaking my brain right now. But where do we exist in that? When you think about that kind of habitable zone, would it be better? Would higher chances of life? Like, we should be pointing all of our SETI observatories, all of our planet hunting stuff coreward, right? As opposed to rimward.
Maybe not. I mean, it is interesting that there are all these juicy elements in the center, but it's probably not the best place, especially for intelligent species to evolve. So honestly, where is the habitable zone or zones in a galaxy? We don't know.
Here. That's all we do know.
At least right here.
Right here.
A very, very small habitable zone.
Yeah, exactly. For a little while. Okay, awesome. All right, let's move. We're going to go back around to the top. We're going to talk to Kimberly, and this is cool. So Project Starshot's got another purpose.
Yes. So the Breakthrough Starshot program, which is targeting the Alpha Centauri system, is actually going to be devoting some of its numerous resources towards building a planet-finding instrument with the European Southern Observatory, It is dedicating some money to build sort of an all-in-one planet hunting instrument attached to the VLT, one of the telescopes on the VLT. And they're actually modifying one of the pre-existing instruments to do a lot more and to specialize it towards hunting exoplanets, which is really cool.
And this is fairly new, right? This idea of planet hunting, to this scale from Earth. I mean, it almost feels. I mean, a lot of there's a lot of Earth-based planet hunting that has gotten done, but I think it's funny how people are almost coming around full circle. Like in the they thought it had to be real spacecraft, Kepler, TESS, Gaia, things like that were going to find the planets, but now there's a lot of really amazing new ground-based observatories that are coming up. There's a lot of really good reasons to have a ground-based observatory.
Not too long ago, the Gemini Planet Imager started detecting planets and actually getting direct images of the planets. And that's actually partly what this new instrument on VLT is going to be doing. They're going to be adding a coronagraph, adaptive optics. They're going to be adding vibration controls for radio velocities, new photometers. So they're really going to be able to survey the Alpha Centauri system in as many ways as possible as we know how to detect exoplanets, except microlensing. They're not doing any microlensing. But
right, but I mean, even really amateurs help out with microlensing.
You can't really set up a microlensing detection, unfortunately, because there's
right. It's just
really
a complete fluke.
There's really nothing between us and Alpha Centauri to use as a lens.
Yeah.
Right. But what's really cool is they're not only going to be looking for planets, they're going to be doing. They're hopefully going to be able to get detections on smaller scales as well. Maybe get some dust measurements, see what any of those tiny little breakthrough Starshot crafts may have to encounter. They may also be getting some detections and measurements for the Proxima Centauri planet, which we still don't know if it transits or not. It'd be really cool if it did. I'm crossing my fingers.
Yeah. So, I mean, we all know of Breakthrough Starshot with their mission to send, a little nano probe to another star. And this is sort of the thing that was announced last year. Yeah. And, with Stephen Hawking and Yuri Milner. Yeah. And, and the great idea, completely science, maybe it's real, but it sure sounded like science fiction at the time. But this is, are they looking for trying to help find the worlds that they should send their spacecraft to? Is this maybe getting a little ahead of the game here?
I don't know that they're so much thinking they're going to find a planet, but one of the big issues with the Breakthrough Starshot program, one of the sort of the things hanging over them was that we've never surveyed the Alpha Centauri system in a lot of detail. And with such sensitive little crafts, we want to know that if we're going to send them there, they're not going to immediately get destroyed by something, that maybe there's something interesting to see. They need predictive measurements. What do they think, once the crafts get there, what do we expect to see so we can compare? We just don't know. And so this is part of their initial stages of this project, is actually surveying the system to see what is there, what is not there, so that they can help build the crafts to the right specifications.
Right. And so, how much does astronomy need this kind of instrument attached to this kind of telescope? The VLT is a monster telescope, and to have an instrument of this sensitivity attached to the VLT, that should be
right. It'll be used for more than just this one star, I guarantee, or this one star system.
Yeah.
As a planet hunter myself, this is sort of like your all-in-one planet hunting instrument attached to one of the largest telescopes in the world, with a very similar system attached to a different telescope, which has already been proven to work. GPI works incredibly well. We're going to essentially do the same thing on VLT, but also with radio velocity capabilities, also with transit capabilities, and it's definitely going to be used for more than this once.
I have a question.
Yeah.
Will it be working in tandem with GPI?
I don't know, actually. I don't know how much they'll be doing both, but I know that a lot of astronomers are going to be looking at the Alpha Centauri system in the coming years, if only to look at Proxima and try and see what kind of environment Proxima is in, the Proxima planet. But I don't know if Breakthrough Starshot's intending to use them both at the same time. I think they would probably have to apply for Gemini time separately.
Is this source of funding any different is this, I mean, there's a lot of foundations. I know, like the SDSS, the Sloan Digital Sky Survey, it's the Sloan Foundation paying for the Sky Survey. Do we see a lot of these kinds of instruments underwritten by organizations like this, by as opposed to necessarily stuff that's coming from like a research organization or a university or just the National Science Foundations, right? Or the European version of that?
I don't think so. I can't think of any others off the top of my head. I mean, breakthrough is a breakthrough for more than just, the name and the SETI goals. It's private citizens directly funding really cool science because it's awesome and it'll lead to great things in the future. So I don't know that anything like this has ever been done before.
We got a question from Elad Avron, which is how optimistic are any of you about the Starshot project? We had a little time on our hands, so I thought we would answer that question.
Gosh.
So how do you feel? And this is, of course, I'll give people the description in case they haven't heard of it. It's this idea that you build these tiny little solar sail spacecraft with these teeny tiny little instrument packages, and then you use a laser to accelerate them to relativistic velocities, say 10 times the speed of light, and use that to get your spacecraft relatively quickly to another star. How do you feel about all that?
Actually, I was just thinking that the story that Carolyn was talking about with Voyager and mapping the interstellar medium is actually going to be critically important to the success of the Breakthrough project.
Paul, what do you think?
I guess,
Not a chance.
not a single chance.
If they actually send one to Alpha Centauri, I will eat a replica
of the spacecraft.
Yes.
it seems
Right.
so science fiction-y right now.
Carolyn, what do you think?
Interesting proof of concept, but I'm kind of with Paul. I'm a little skeptical about how well it's going to work. I hadn't thought about the thing that Kimberly brought up, which is Voyager and HST studies of the interstellar medium, but that would be pretty critical.
It has to get through all that space to get there first.
Yeah, let's get it out of the heliosphere. Yeah.
It'd be good to know that it'll actually survive and make it there.
My feeling on it really is that it's a really fascinating concept for just exploring our solar system, that you could, instead of trying to boost it up to relativistic speeds, why not just take, like, say, a year to get to Pluto instead of 10 years? Like, that technology probably has all kinds, and the spacecraft could communicate back. Like, I think we could do a lot more exploration in our solar system for starters. And if it turns out that technology works, it's been figured out, then by all means blast a few towards Alpha Centauri. But it seems like it's almost like to get everyone's attention, they needed to go with the big version as opposed to one of the smaller versions. So that's my feeling on this. But I love Paul always bringing us down.
Hey,
Always crushing dreams and hopes.
I'm still hopeful. They have not yet shown me that they can't do it. There's just a lot of things they haven't proven that they can.
When you get your PhD, they tell you all the secrets.
Oh.
I see.
Is all my optimism going to go out the window with the PhD?
Yes.
When they reveal the secret truth.
That's before they bring you the bottle of champagne.
Hazing ritual, right?
Wait, there's supposed to be bottles of champain? All I got was
That's for your
crushing.
super
Was it
PhD.
degree?
They were in my department.
Yeah, but I mean, at the same time, here they are paying, funding a wonderful instrument for a great observatory.
Yeah.
So,
I mean,
not gonna
whether
let
or not
that-
they make it to Alpha Centauri aside, there's still going to be some great contributions to other areas of science as well. And like you said, surveying the solar system is something we've never done either.
Yeah. Someone asked me a question like, what worlds have we not really explored enough? And I was
All
like,
of them.
all of them.
Earth?
Yeah, Earth we've got kind of locked down pretty well. But even like the moon.
Depths of the ocean, Fraser.
Yeah, that's true. We've only explored chunks of the surface of the Earth. We haven't even looked at the bottom of the ocean. But you think about, Neptune and Uranus need to be revisited. All of the Galilean moons, the big
Venus
four.
again. Venus got pushed off again.
Yeah, and like from the clouds, maybe something ground based. So we really only just started understanding and exploring. And so if this Starshot is a method for getting around, sending a very usable probe to all kinds of places, wouldn't it be amazing if we could send $100 spacecraft thousands at a time to every corner of this entire solar system? That alone will keep us busy for hundreds of years. So,
I could take or leave Mercury.
really? You don't even want to know if there's like water ice in hidden craters and okay, fine.
No.
Then all these worlds are ours except for Mercury. Mercury's forget it.
Mercury gets no love.
No, we're gonna tear Mercury apart and turn it into a Dyson sphere. That's just that for it.
That's not our stuff.
That's small. A Dyson swarm. All right.
I know. We'll make the swarm really compact.
Yeah, a very small swarm.
Compact makes a sphere, and we'll put it in the orbit of Mercury, and we'll just call it Mercury 2.0.
We'll make an alien megastructure.
Microstructure.
I didn't say the words.
I know you didn't say it.
Terrestrial microstructure.
I know you won't say it, so that's all right. It's my job to say it. All right, let's move on. It's too bad we never get a chance to really. We're always going so fast. We never get a chance to really talk about this kind of stuff. Anyway, all right, Carolyn, let's talk about a cool photo from Mars. And I'm going to show a picture of this, so you can talk about it, and I'll show it.
Yeah. Speaking of aliens looking back at our planet, so in about 20 or 30 years, when the first Martians from Earth are standing on the planet looking through their Palomar Observatory, this picture is what they might see. Except it wasn't taken 20 or 30 years from now. It was actually taken a couple of months ago with the Mars Reconnaissance Orbiter high-rise camera. Took two images on I think it was the 20th of November and composited them together. So they're at the right proper phase angle and everything of Earth and the moon.
Yeah.
And so if you had a really good VLT type telescope on Mars in about 20 or 30 years, this might be what we see. The thing that really captured my attention about it, and this made the rounds really quickly at AAS. I think it was released the first day of AAS, was just everybody just kind of standing there saying, holy, what? Because it was so cool. And there are very few pictures that come to AAS like that. I mean, the Hubble Deep Field was one where everybody just kind of stood there and looked at it and said, oh, it's galaxies all the way out. Well, here we have Earth from Mars, and
and the moon.
And the moon, yeah.
Yeah.
So this says a lot more to me. I mean, the pale blue dot picture said a lot to me because basically Carl was telling us, everybody you knew and ever loved is on that planet. Here it is, the same thing, but now we can actually make out continent-sized details. Clouds.
I'm putting the picture up now. So which part of the Earth is that? Is that Africa?
Yeah, I can't really tell.
Yeah, we can definitely see there's like some kind of dirt, and there's some kind of blue, and there's some white splotches over it.
It does kind of look like it, doesn't it?
Yeah,
I'm looking at a blow up of it on the NASA page.
Yeah, and then the moon. Now, obviously, the Earth and the moon, they might be that difference in size, but they're not that difference in distance. So I don't know whether we're getting a perspective of the moon, or
I'm not sure they could get them both in the same field of view, so they had to take two pictures.
Yeah, or they had to sort of move it over. And sorry, and what was the spacecraft that took this picture?
The Mars Reconnaissance Orbiter. It's their high-resolution camera called HiRISE.
Right, and so that that's the largest magnification, the best telescope that is outside the Earth's
essentially
orbit.
That's it. It's the best camera orbiting Mars at this point.
Yeah, or anywhere in the solar system.
Earth from Mars.
Yeah, I wish there was some way we could get pictures of Earth from closer up, but this is the best we'll ever be able to do.
That's what we got for right now.
But it is funny to think that in the future, right, Martians will stand on the surface of Mars, look up, and see Earth as this.
Well, they'll see that blue dot. They'll see the bright.
It'll be a bright star, and then they'll use a telescope and they'll resolve the globe, and they'll see something kind of like this. And as you said, once they get Palomar, the pictures, the Martian, big observatory, the pictures of Earth will start to look as good as stuff you could take from,
Well, and here it is, basically us looking back at Mars like we've been, at Earth like we've been looking at Mars.
Yeah, exactly. This is exactly what in War of the Worlds the Martians saw as they planned to invade our planet.
Mars attacks. Yeah.
All right, Paul Metzetter.
It's a very evocative picture.
Tell me about a new star in the sky.
A new star, not just a new star visible to the naked eye, predicted to appear in the constellation Cygnus in the year 2022, plus or minus a year. Astronomers have been studying a star for the past few years, and a couple years ago, they realized it wasn't just one star that was variable and pulsating, changing in brightness. It was actually a very compact binary, so compact that the star's outer gaseous atmospheres were actually touching. So it's called a contact binary. They're orbiting around each other really, really fast and losing angular momentum. So they're inching towards each other every single day. And by studying the behavior of this system over the past few years and comparing it to a surprise nova that happened back in 2008, and looking at historical archival data from before that surprise event, they realized that this new star that they're observing right now is on the exact same path as that star that blew up in 2008. So just running the simulations, running the models forward, they predict that these two stars are going to finally merge. They're going to slam into each other in 2022, and it's going to be bright enough. It's going to be something like 10,000 times brighter than they are now, which will make the star visible in the night sky, which is kind of cool.
How visible?
It will be amongst the brighter stars. It will definitely be a red star. These kinds of merger events, because there's so much dust and gas swirling around, the light that's emitted looks very, very red. And in fact, I learned a new word today.
Yeah.
The new word is merge burst.
Merge burst.
Merge burst. It doesn't exactly roll off the tongue, though.
So hold on. I mean, I understand this idea, right? That you've got these two stars. They formed a long time ago. They were orbiting one another, and they're different ages, maybe? Is that right? And
it looks like both of these stars are main sequence.
Okay, so they're main sequence stars that just formed so close that now they have turned into a contact binary, and now they're marching their way to
They're on the death spiral.
Right. When they do merge, what kind of an object will this be? I mean,
that depends on the masses of it depends on lots of stuff. It depends on the masses of the stars themselves. It depends on the violence of the collision, of how much stuff is ejected from the system. It depends on the angular momentum at the time of impact, et cetera, et cetera, et cetera. This might settle down after a few years to be just another slightly bigger main sequence star. This might trigger a nova outburst, a helium flash or something. This might trigger a core collapse if they're big enough. I don't think we know enough about the stars themselves to be able to predict the final end state.
Because I know that we've got situations like we've got these ideas of blue stragglers, which are these in globular clusters where they can, one star can consume another star, and even though it's a fairly old star, it turns blue because it's It's acting like a much younger star because you've just got this fresh feed of material. So I'm just wondering, but as you said, if you've got two main sequence stars, they're roughly the mass of the sun, give or take a bit. You're not going to get a neutron star. You're definitely not going to get a black hole, but you're going to get something.
It may even be totally disrupted. There may be no star.
Right.
You end up totally nebulized. But the brightness of the flash doesn't come from any fusion processes. It actually comes from the stars themselves slamming into each other. There's merger shocks. It's a very high energy event, which releases a lot of energy.
And I was just looking at the article that you linked to it, that it's going to increase 10,000-fold and become one of the brightest stars in the northern hemisphere. It's going to be in Cygnus, and it's literally going to add a new star to Cygnus.
Yes.
Which is...
So it'll be like the new Cygnus, like Gamma Cygnus or something.
Yeah. And then, and we are in unknown territory, right? That what happens after that point, whether it just dissipates entirely, whether it takes tens of thousands, hundreds of thousands, millions of years to chill back out? We really don't know.
Yeah, it'll be really interesting to compare the further evolution of this system to the one that went off in 2008, because they had very initial or very similar lead up events. And we'll get to see, do they end up in the same kind of state? Do they end up in different states? We'll learn a little bit of science.
For once.
For once.
Yeah. Yeah. So, I mean, is there a place to see this the best? I guess you got to be able to see Cygnus.
Yeah, just look at Cygnus, and it looks like, comparing to that star went off in 2008, it will be visible for at least a few weeks up to a few months before it'll dip back down.
Ryan Schmitz wants to know, how could we get some gravitational wave data from this merger? Do you think it's going to be violent enough for gravitational waves?
Obviously, this kind of system will emit gravitational waves, but the gravitational waves that we're capable of detecting right now with advanced LIGO are from the mergers of black holes that are dozens of solar masses each. And these stars are main sequence stars. They're at most a few times more massive than the sun. So probably it's below the detection threshold of LIGO.
Yeah, actually, they were asked that question at the press conference at AAS, and everybody just kind of threw their hands up going, oh, wouldn't that be cool if we could?
But they are emitting gravitational waves right now.
Yes, absolutely.
So whatever gravitational waves they emit when they actually collide, you would be able to detect there, because they're as close as they're going to, they're as close as they can be without merging and just wiggling around each other, and that's gravitational wave city. Mm-hmm. Now, we got a couple of questions here. People have got a whole pile of questions, actually.
Right.
Benjamin Val wants to know, would this be a bad day for any life close to it?
Absolutely.
A terrible, no
I think, as
day.
I was reading up about this article, if one of these events happened within 100 light years of us, it would be bad news for us.
But that's like supernova level of bad event, right? I mean, is this going to release as much energy as a supernova?
No, it's less than a supernova, but more than a typical nova.
Yeah, so it's probably safe to say what happens in Cygnus is going to stay in Cygnus.
There you go.
Right, but the point being that any life, and I guess one of the interesting things is that you actually could have life. You could have stable planets, because if you've got these two stars orbiting around each other, you could have planets going around this center of gravity, no problem, for long periods of time. So there could very well be life on worlds surrounding these stars, and they are indeed about to have this very, very bad day.
Too bad for them.
Too bad for them.
Starshot project funded. Let us know.
Sev Dust Bunny wants to know how far away they are, but then someone else said about 1,800 light years.
There you go.
And then from Rarnstrom wants to know, we have a hard enough time predicting uncontrolled re-entry of satellites. How sure are we about the timing of this merger? I guess, how sure is Larry Molnar of this merger? But
they're pretty confident. Of course, they could be wrong. It could be that it's just a pulsating star. It could be that we're misunderstanding the timescales involved. It is a hypothesis, and we'll find out in 2022, won't we?
Yeah, this is like perfect science, right? You are making a prediction. You are saying that something's going to happen in 2022, roughly, and you should see this in the sky. And if you do see that, then hypothesis confirmed. And if you don't see it, then it's time for another hypothesis.
Yeah. The perfect timing to test a hypothesis is 3 years from the current grant deadline.
Is that how that works?
Yes.
Right. That's for maximum funding. Awesome. Cool. Well, I think we've reached the end of this week's Weekly Space Hangout, and we're all out of news. Actually, there's a mountain of news because of the AAS, so this is just literally just the tip of the news.
I am no help with that. I was presenting dissertation things at AAS and was not paying attention to anything else.
You weren't paying attention to any of the news.
I was a terrible conference attendee.
Whenever I go to the AAS, I find it's really tough because you're in the middle of this hailstorm of news. A lot of it is super interesting, and you want to report on it as much of it as you can. Half of the interesting stuff is released as a press release, and then half of it you have to attend a talk, and someone goes, "Oh, and by the way, here's this picture of Earth from Mars." You're like, "What?" And you want to get your hands on that picture. So it's a funny place to go. I find it really tough to report from the AAS because I sort of want to both see everything that's happening, and also we have a job to do. We actually figured out. We used to attend, and so whoever was attending the AAS, their job was to not report on anything that had a press release. So they couldn't touch any of the news that had a press release, because we could all just look at the press releases and report on them back from home, but whoever was there could then find stuff on the ground that was super interesting. So it's a great time. If you ever had an opportunity to go to the AAS, I highly recommend it.
It's a fire hose of astronomy. There's no question about it.
Yeah, they
Fire
all
hose of
are.
science.
A fire hose of science. That's awesome. All right, well, let's sort of wrap things up and give people a way to find out more. Let's start with Carolyn. Well, where do people find out more?
Thespacewriter.com, and you can find me on Twitter at spacewriter.
Perfect. Dr. Paul Matt Sutter, where do you find out more?
You can follow me on Twitter and Facebook at Paul Matt Sutter. My website, pmsutter.com, is also chock full of useful information. I also have my own podcast, Ask a Spaceman, askaspaceman.com, which is supported by patreon.com/pmsutter. People like you. And don't forget the amazing Iceland Aurora excursion, February 2018, with me and Mr. Cain. Sign up at astrotouring.com. I've been doing lots of ads recently.
You really have.
Advertising more.
Kimberly, where do people find out more?
People can find out more by following me on Twitter at AstroKimCartier, at my website, KimberlyCartier.org, and by coming back to this show next Friday, where I will be the special guest talking all about my recent paper about the atmosphere of a hot Jupiter and all the work that I've been doing for my dissertation.
That's awesome.
Definitely tune in next week.
People are watching you get your PhD in real time.
In real time. Yeah, I also started a blog series about what it's like to get my dissertation in real time.
Yeah. Well,
real people and feelings and stuff.
We watched Nicole Gallucci go through this process, and now she's out the other side, and then I am, contractually bound to call her Dr. Nicole Gallucci at every moment. Yeah, so that's going to happen. You ready?
Yeah.
Dr. Kimberly Cartier.
The first show that we do after I get my PhD, I'm going to wear a little party hat.
Or the little graduating. Yeah.
It'll be great.
That sounds great.
Come in your robes.
I'll come in my robes. Yeah.
That's awesome.
It's a bit unfortunate my last name changed. It used to be Star, and I would have been Dr. Star, the Star Doctor.
Oh.
That would have been cool.
That was an opera. I don't know why you would change your name. Okay, cool. Well,
so fun.
All right. So once again, I'm Fraser Cain. I want to remind everybody that this is more than just us just talking at you, but this is actually a interactive community. So if you want to take your love and interaction with this show to its next level, you're going to want to go to the Weekly Space Hangout crew. That's at wshcrew.space. How cool is that? And then you can join our Slack community. And we've got, I don't know how many people in the Slack community now, dozens. And that's the chat that's going on at the bottom of the screen that some people think is super distracting, but I like it. And then, but also, the important thing to know is that the folks at the WSH crew really are the producers of this show. Alan Stern, the project director for New Horizons, is going to be here on February 10th. Why is he coming here? Because they just said, "Hey, Alan, do you want to be on the show?" And he said, "Sure." So I think that if there's guests, if there's people that you want us to talk to here on the show, join the WSH crew, become one of the executive producers of this show, pick whichever guests you want. I'll interview them. I'm ready. You just let me know who you want to talk to.
One of us.
If you can get Elon Musk on the show, I will be glad to talk to him. So thanks everyone for joining us this week. Thanks to all of our guests. I'm going to bring you back into the Brady Bunch mode, And thanks to all the chat and the great questions. I'm glad we had a little more time. I forget how much I really kind of enjoy having a little more time to be able to talk about these stories and for us to philosophize. So no Astronomy Cast after this because we did just do Astronomy Cast on Wednesday, and then Pamela's traveling. So that's it. Everyone have a great weekend, and we'll see you all next week.
See ya.
Bye.
Oh, Paul wasn't waving.
Paul, wave.
Oh, sorry.
There we go.
We're all
There it is.
waving except for
Sorry.
you.
All right. We'll see you later.